Good afternoon, students. How are you? Hope you are fine. In this unprecedented time of pandemic, our life is a blessing. So enjoy each and every moment of your life. Welcome to my physics class. Me, Mafra Shati. Today, I will take the class for HSC Physics. Today's topic, Kirchhoffs Law from the third chapter of Physics second paper. Look at this circuit. In this circuit, there are some resistor and two cell or battery are connected. This type of circuit you have solved in your in the syllabus of 9-10 level, and that time you solved in a circuit by using Ohm's law, because that time the circuits which you have solved were simple circuit, and in case of simple circuit Ohm's law is applicable. But in case of critical circuit, Ohm's law is not applicable. That time you need Kirchhoffs law. You need to apply Kirchhoffs law. Kirchhoffs law. Now, I will give you the idea about Kirchhoffs law. Kirchhoffs circuit laws allow us to solve complex circuit problems by defining a set of basic network laws and theorems for the voltage and currents around a circuit. We saw in the resistor tutorial that a single equivalent resistance can be found when two or more resistors are connected together in either series, parallel, or combinations of both, and that this circuit obey Ohm's law. That, as I have told earlier, in the syllabus of 9-10, you have solved many circuits. That time you found out the equivalent resistance of two or more resistors. I think you have remembered, isn't it? So by using Ohm's law, you have to found out the equivalent resistance of series and parallel circuit or the combinations of both. However, sometimes in complex circuits such as bridge networks, we cannot simply use Ohm's law alone to find the voltage or currents circulating within the circuit. For this type of calculation, we need certain rules which allow us to obtain the circuit. Kirchhoff's law has two parts. Its first part is known as the first law, that is the current law, and in simply you can write KCL, Kirchhoff's current law, or KCL states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all the currents entering and leaving a node must be equal to 0. I exiting equal to I entering. This idea by Kirchhoff is commonly known as the conservation of energy. Why it is conservation of energy? Because you know from the conservation of energy, conservation of charge. I have told wrong. Conservation of charge. As you know, from the conservation of charge, charge is neither created nor destroyed, only transfers from one body to another body. You have seen in chapter maybe 10 from your 9th syllabus, when two objects are wrapped together, then charge from one object transferred to another object. So no charge is lost or gained, only transfer. Like this way, the junction doesn't store any current. So the current entering into the junction is equal to current and leaving the junction. Here you can see in the figure I1, I2, I3, I4 and I5 are different current. Those are connected with this junction. Here by the direction you can see I1 is entering into the junction, I2 is entering into the junction, I3 is entering into the junction, whereas I4 and I5 are leaving the junction. Okay, so as I have told you, the currents entering the node equals to current leaving the nodes. Here the three currents entering the node I1, I2, I3 are all positive in value. You will take those as positive. Here, I can give you a simple example for that. Suppose in your family there are 5 members. Suppose 4 other members are entering into your house, are added into your house. Then the number of family members will be increased, isn't it? So that can be taken as positive. And if some of the members are leaving the house, so the number of family members will be decreased. So that can be taken as negative. Like that way, for simplicity for calculation, here you will take I1, I2, I3 are all positive as they are entering into the junction. And the two currents I4 and I5 are taken as negative because they are leaving the junction. Look at the equation. I1 plus I2 plus I3 minus I4 minus I5 equal to 0. The term node in an electrical circuit generally refers to a connection or junction of two or more current carrying paths or elements such as cables and components. Also, for currents to flow either in or out of a node, a closed circuit path must exist. We can use Kirchhoff's current law when analyzing parallel circuits. You know, in parallel circuits, the current is divided, isn't it? So, you have solved those type of problem. As I have told you in 910, you have this chapter that is current electricity, and there you can see in series circuit same amount of current flows through all the resistor, but in parallel circuit the current is divided. Different currents are flowing through different resistors. I think KCL, that means Kirchhoff's current law, is clear to you. Now I will explain you Kirchhoff's voltage law or KVL. See, in short form, it can be written as KVL. KVL states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to 0. In other words, the algebraic sum of all the voltages within the loop must be 0. This idea by Kirchhoff is known as the conservation of energy. Look, this is the closed loop. Okay, this is the closed loop. There are different resistors. 4 resistors are connected in this circuit. Here, if you starting from A to A, B, C, D, again if you come to A, then the voltage drop within these 4 are the summation of voltage through all the voltage drop through all the resistor will be 0. That means if you start from A and again come to A, then the sum of the voltage will be 0. So in KCL, you can see summation of I equal to 0 at a junction, and in KVL, in a loop, the summation of voltage will be 0. These two laws enable the current and voltage in a circuit to be found. That means by applying KCL and KVL, we can calculate current and voltage in a circuit. The circuit is said to be analyzed, and the basic procedure for using Kirchhoff's circuit law is as follows. You don't need to memorize this point, but you have to remember how can you apply the both law in order to solve any circuit. Assume all voltage and resistance are given. If not level, then if not if voltage and resistance are not labeled, then label them as V1, V2, R1, R2, etc. Assigns a current to each branch clockwise or anti-clockwise. Label each branch with a branch current I1, I2, I3, etc. Find Kirchhoff's first law equation for each junction. I have already told you that means Kirchhoff's first law is the law for the it is used to solve it is applicable for any junction or node. And find Kirchhoff's second law equations for each of the independent loop of the circuit. Now, by using KCL, how can we solve any circuit, or how can I find out the value of current? Look at this figure. Here I1, I2, I3, I4 and I5. Suppose these 5 currents are entering into the junction. So look, in figure 1, I can write I1 plus I2 plus I3 plus I4 plus I5 equal to 0, because here in figure 1 all the currents are entering into the junction. So the summation of the current will be 0. Look at this figure. Look, here 1 ampere current is entering into the junction. Then 1 ampere current is entering into the junction. Then 2 ampere current is leaving the junction. 3 ampere current is leaving the junction, and the current and this current, and we have to find out this unknown value of current I that pass through this resistor. So we can take that this is entering into the junction. Now how can we find out the value of I? Okay, look in figure 2. The current which are entering into the junction must be positive. So 1 plus I is also entering. 1 plus I equal to 3 plus 2. So the value of I will be what? 4 ampere. Okay. Look at this figure. Here 1 ampere current is entering into the junction. 2 ampere is leaving. 3 ampere is leaving. And the current which I will find out the value of current that is going through this resistor, we take that is leaving the junction, that is I prime. So the value of I prime by applying KCL we can solve is 4 ampere. Here it will be minus 4 ampere. Sorry, I have not given. Now, by applying KVL, I will solve this circuit. Dear students, you have to understand the application of KCL and both KCL and KVL to any circuit. If you understood at first, then you can solve many other circuits. And in the next video, I will give you some circuits to solve. I will show how to solve the mathematical problem circuit based. Look here in this circuit. This is the cell here 2 loop. This is loop 1 and this is loop 2. And in loop 1, one cell is connected, that is E1, and in loop 2, another cell is connected, that is E2. So this is the low potential, this is high potential, this is negative, this is positive side. So if we want to starting from this point, and want to voltage drop through each resistor, voltage can be drop or voltage can be gain. If voltage if current goes from high to low, then voltage will be drop, because but if current goes from low to high, then voltage will be gain. Look, the current is going through this direction, and if we want to measure the voltage through the resistor along the direction of current, then the voltage drop will be taken as positive. Look, sorry, here I1 current at this junction or node will be divided into two parts. That is, I1 will be divided into I2 that goes along through R2 and I3 that goes through R3. Here I3, again at this node, I2 plus I3 becomes I1 and that goes through R4 and come to this point again. So if we want to measure the voltage drop by following the path of the current flow, then the voltage drop will be taken as positive. Okay, so the voltage drop through R1 will be what? According to Ohm's law, you know V equal to IR. So I1 plus R1. Then if we consider this loop, that means loop 1, and if we measuring the voltage by clockwise, okay, here the current is flowing through clockwise. Look, clockwise direction. Here the current is moving clockwise direction. So in clockwise direction, as I have told you, if you want to measure the voltage by following the path of current, then I1 R1, that is the voltage drop through R1, plus I2 R2, that means this one, through R2 the voltage drop is I2 R2, and here I1 R4, these all will be taken as positive. But in this way, if you move, and then when you get the voltage, when you get the cell, that time the sign of the cell which you see at first, you will use that sign. That means here, while moving in this way, when you come here, you see the negative sign at first. So you will take here minus E1 equal to 0. And in the second loop, suppose you want to measure the voltage by moving anti-clockwise. Okay, current is moving in this direction, but you want to measure the voltage by moving anti-clockwise. That means you want to go against the direction of the current flow. That time the voltage drop must be negative. Okay. Look, the voltage drop through R3 will be what? I3 R3, but I3 is moving this direction and you are measuring the voltage by moving anti-clockwise. So it must be negative. That means minus I3 R3. Again, the current I2 is moving this direction and you are measuring the voltage also this direction through R2. So here the voltage drop I2 R2 will be positive, and in this way you are moving, and when you reach to the cell, you see the negative sign of the cell at first. So you will use the negative sign, minus E2 equal to 0. This is second equation. From these two equations, you can't solve, you can find out the value of R1, R2, R3, R4. So you have to apply KCL at the node. Look, here at this junction, I1 equal to I2 plus I3. So from if you use this equation in this equation or in that equation, then you can solve the value of R1, R2, R3 in this way, or I1, you can find out the value of the current if the value of resistor or the value of voltage is given. I will show you this type of math in the next class. Today I just explained what is KCL, that means what is Kirchhoff's current law, and what is KVL, and how to solve any circuit by using KCL and KVL. So KCL means, again I want to summarize, KCL means summation of I equal to 0 in a junction, and KVL is applicable for a loop, closed loop. You have to remember, in a closed loop the summation of the voltage equal to 0. So, and you can take the current, you can take the current as clockwise or anti-clockwise both. So in this way, by using KVL you can solve any circuit and you can find out the current through each and every resistor. So today I want to finish my lecture. In the next video I must show you some mathematical problem. Those are circuit based. At the end of my lecture, I want to give you one moral, that is, difficult roads lead to beautiful destinations. Thank you everybody.